All right, Micah and Taryn, you two are the ones absent. This is for you. We are starting our new notes. Everything we've done with trig so far, in the whole week we've done trig, has been based on a triangle. You can also do trig using a circle. And and Hilburn is sitting here in the front row going, Now, today's lesson is really terminology. You got vocab to learn. Here we go. First piece. We're going to draw those three angles. No protractor. We're just going to ballpark things. I'm not going to tell you everything as we draw them. We're going to draw them first. You draw what I draw. I'm going to start my angle right there. And you know each side of an angle is called a ray. Okay. Now, 215 degrees. I'm going to count as I go. I'm not counting 1, 2, 3. 90 degrees, 180 degrees. Now, if I go on to the next axis, that's going to be 270 degrees. I don't want to go that far. How much farther? A little bit. There's my angle of 215 degrees. Now, there are 4 things you have to have when you draw a circular angle. We have 3 of them. I will get to all that in a minute. The last piece we need, what is that angle right there? What is the measure of that angle?
Are we talking like a vertical angle?
We're not thinking theorems, but you can. Let's measure that angle. So what is it? 250 minus 180? What's that? Or 215 minus 180? What's that? What? 55? 35. Try 35. Try 35. Daly, how'd you get 35? What did you do? Why did you pick 180? Yeah, you learned in geometry a straight angle. You remember a straight angle? Yep. A straight angle has measure 180 degrees. So we went 180 degrees plus how much? Plus 35 more. Now we have all the parts. I'm not naming the parts yet. Next angle. 575 degrees. 90, 180, 270, 360, 450, 540, and a little bit. No, not to scale. Oh my goodness, no, this is not to scale. Oh, it's a snail. Oh, it looks like a snail. Oh, okay, I thought it says not to scale. Okay.
Wait, that angle looks like the same thing as the angle to the left.
Okay. So Abby said this angle looks like the same angle to the left. It's because it is. In a way. In a way, it is. You say, well, wait, the angle measures are different. Right, so they are different angles, but there are similarities as well. Now, here's what I need you to think. What is the measure of that green angle? How'd you get 35?
Full circle more. So 575 and subtract 360.
You said 575 minus 360. What's that?
There's 360 degrees in the circle.
360 degrees in a circle, so you essentially took one full circle out. And what were you left with? 215. Oh. Okay. And 215 minus 180 is 35 degrees. Now, you also could have thought of it this way. 180, right? 360, 450, 540. So 575 minus 540 is 35 degrees as well. Your classmates are making very strange noises back here. I'm not sure what's going on. Last one. Last one. Negative 145 degrees. What? Negative 145 degrees. 90. Oh, if I go all the way to that x-axis, I'm going to be at 180 degrees. I don't want to go that far. I'll just make that bigger. I used to like tricks. He's talking about the cereal, by the way. You know, yeah. I'm talking about the cereal. What is the measure of the green angle? If you're guessing 35, don't guess. Fine. 180 minus 145 is 35 degrees. Okay. Now let's start naming stuff. What is one thing that all three of those angles have that's the same? They all start in the same place. Where is it? The vertex is where? The vertex. No, the vertex. The vertex is at the origin. This side right here is on the positive x-axis. Ladies and gentlemen, when you have an angle whose vertex is at the origin and that starts on the positive x-axis, that angle is in standard position. So, standard position. An angle is in standard position when its vertex is at the origin and the initial side is on the positive x-axis. You better know that. An angle is in standard position when its vertex is at the origin and the initial side is on the positive x-axis. So all of these angles are in standard position. Okay, so far? All right. So, let me see. Okay, so this right here, that's called the initial side. This right here, after you do your rotation, where does the other side of the angle end up? That side is called the terminal side. We will not finish these notes today, no. You know. That does not what, no, that's not what it means. Ha! I'll get you on this one. Now, every one of these angles has the same initial side and the same terminal side. You buy that? All right, so what do they have in common? Same initial side and same terminal side. Whoops. What else do they have in common? That 35-degree angle. Now that 35-degree angle has a special name too. It's called the reference angle. These are the only two bullet items we're going to put under this, by the way. Same reference angle. Are you okay with that little notation for angle? Here I'm going to give you the definition of a reference angle. Take a look at that 35-degree angle. A reference angle is always acute, and it is always between the terminal side of the angle and the x-axis that's closer to it. So, reference angle is an acute angle with the side. All right, sorry, I had to erase 2 words. An acute angle that the terminal side, come on, Stennett, get a clue, that the terminal side makes with the closest x-axis. So a reference angle is an acute angle that the terminal side makes with the closest x-axis. You got that written down? Now, I'm going to erase this because I don't have enough room to do the next question. But I want to go down here, get us some room, and what we're going to do is we're actually going to find some reference angles. You don't have to write these down. Let's just try a few. That's just crooked, but pretend it's not. Pretend that's not either. Okay. Okay, there's my angle. And that angle is 140 degrees. In what quadrant is the reference angle? In what quadrant is the reference angle? Quadrant 2. The reference angle sits right there, that the terminal side makes with the closest x-axis. That's the reference angle. What is the measure of the reference angle? 40 degrees, 180 minus 140. If it's on the y-axis, it does not have a reference angle.
So like if it's like a 40, like a P45, so like it's like this, would there be reference?
I'll do one like that in just a second. What about this? And that angle is 350 degrees. What quadrant is my reference angle in? Quadrant 4. What is the measure of that reference angle? 10 degrees. 360 minus 350. 10 degrees. You get the idea of a reference angle? Now, here's what Chance just asked. What if I draw... Well, I should have done this. That angle is 60 degrees. What is its reference angle? 60 degrees. Yep. Anything between 0 and 90 degrees is its own reference angle. Okay?
Oh, it's not,
If it's at 90, it does not have a reference angle.
so it would be 30 down to 40.
Yes, but that's not anything to us. For Micah and Taryn, let me explain what was just asked. The question was, well, isn't that 30? Yeah, but that's not anything. That's not the reference angle. Now, according to Mr. Siegert, remember Mr. Siegert? French teacher. I taught Mr. Siegert in this class. Mr. Siegert used to like to put the reference angle there because he knew it made me mad. Because he knew it wasn't right and he'd do it anyway. Do not do that. I'll count it wrong, just like I did on his. Okay, we have a question, so I'm going to answer it. Like that? Now, where is the reference angle? It's always to the closest x-axis. It's between the terminal side and the closest x-axis. The reference angle is right there. Always. Always. Which would be here, 45 degrees. Now, the last question people are having is, what if the angle that you draw is a right angle?
Or 180.
Okay. 90 degrees. By definition, a reference angle is acute.
Yeah, if it's right angle, that's not.
You cannot draw an acute angle between that terminal side and the x-axis. An angle whose terminal side is on an axis is called a quadrantal angle.
Big word.
A quadrantal angle. Quadrantal angles do not have reference angles. So the other quadrantal angles, 180 degrees, 270 degrees, 360 degrees, they are quadrantal because their terminal side is on an axis.
Would it be Pythagorean?
No, there's not one. Doesn't exist. Okay. What is the one difference that all of those angles have that we drew up there that have a mess on them now? Well, the degree measures are different, but what in the picture is different? The amount of rotation and the direction of rotation is what's different. The amount and direction of rotation. That's what's different. Now, you got that? The first two angles were rotated which direction? Clockwise or counterclockwise? A positive angle measure has counterclockwise rotation. You need to write that down. A positive angle has counterclockwise rotation. Positive angle measure has counterclockwise rotation. That's counterintuitive, isn't it? You don't think it ought to go that way.
Yeah.
But it goes the same way that the quadrants do. All right. I don't know why the quadrants go like that.
Because, yeah, it should have been like this.
I don't know why it's not 1, 2, 3, 4. I don't know.
Just started-
Or started here and made that one. Yeah. I don't know.
just read left to right.
Yeah. Well, we do. You need to keep in mind algebra was discovered in Iraq, I believe. Middle East, for sure. I think it was Iraq, but I could be wrong. The Arabic people, actually, the Persians, they are the ones who came up with algebra, right to left.
That's why.
Hebrew is done right to left.
That makes sense now. I get it.
So it's very possible that it's from there.
Okay.
We have a Hebrew Bible. Can't read a word of it, of course. One of our best friends in college was from Lebanon. And anyway, he gave us a Hebrew Bible. It's the writing, and it's beautiful. That's all we can do is look at the writing. It's beautiful. But yeah, it's right to left. Here we go. Now, based on what you have seen so far, what are the 4 vital things that all circular angles must have when drawn in standard position? You must have an initial side, vertex at the origin, The side is on the positive x-axis. That's one, the initial side. That's one thing. You must have an initial side whose vertex is at the origin and the ray itself is on the positive x-axis. Good so far? You must have a terminal side. The vertex or the end point of the terminal side must also be at the origin. You must have an arrow of rotation. And you must have a reference angle. Those are the four things that you have to have. Initial side, terminal side, arrow of rotation, and a reference angle. Now, we already answered the last one, didn't we? Did we answer the last one?
Sure.
All three of these angles up here are called coterminal. Coterminal angles have the same initial side and terminal side. So, right down here, definition of coterminal angles. Angles with the same initial side and terminal side. We gotta hurry. All three of these angles are coterminal. How many angles are coterminal? Have I got them all? Are 575 and negative 145 degrees the only angles that are coterminal to 215 degrees? Get your calculator, blank screen on your calculator. And I just want you to type in 215. Now add 360. There's your 575. Now subtract 360 twice. There's this one. You could just add or subtract a whole bunch of 360s, and every one of those is going to be coterminal to 215 degrees. You could keep going. Every angle has an infinite number of coterminal angles because you could keep adding and subtracting 360 degrees. That's right, because we just keep either adding or taking off full circles, increments of 360 degrees. That's exactly right. All right. Draw the angle negative 470 degrees in standard position. Here's what you're going to do. You're going to have three angles here. 1, 2, 3. We're going to draw negative 470 degrees in standard position. Which direction is the rotation going to go? Counterclockwise. No.
Clockwise.
It's a negative angle.
So
Negative angles go clockwise.
down first.
Negative angles go clockwise. 90, 180, 270, 360, 450, and a little bit. There's the angle. That red angle is the angle. Do I have everything down that I need to have for a circular angle? I don't have the reference angle. What is the reference angle? What was this little bit that we went over? 20. So 70 degrees is my reference angle. That is negative 470 degrees. Now, let's come up with a positive angle that is coterminal to negative 470 degrees. What are you going to do on your calculator? Type in negative 470. Add 360. To what? 250? 250? Yeah. What direction? Positive angle, so counterclockwise. 90, 180. If I go all the way to the next axis, that's 270. I don't want to go that far. What's my reference angle? I went 180, and then I had to go extra. 250 minus 180. Now, can you come up with a negative angle that is coterminal to negative 470 degrees? Negative 110? Is that what you got when you did negative 470 plus 360? Okay. Here we go. What direction is our rotation? Clockwise. 90 and a little bit. How much is that little bit? That little bit is 20 degrees. If that little bit is 20 degrees, what's this? Ladies and gentlemen, you just found three angles that are coterminal to one another. Same initial side and same terminal side, same reference angle. All right. Just as segments can be measured using inches and centimeters, angles can be measured using different units of measurement. You have only ever measured an angle using degrees. You can also measure angles using radians. Ladies and gentlemen, welcome to radians. This is awesome. Oh, shush. Now, radian measure is based upon what is called the unit circle in trig. By definition, a unit circle is any circle with radius 1. 1 inch, 1 mile, 1 yard, 1 foot, 1. Now, Taryn and Micah, this is where I have to go offline. I've got to go to the dot cam. This is going to be the last thing we do in class today, so I will just have to catch you up with this another time. Toodle, toodle.